Hi and Assalamualaikum, Miss Ita. Today, me and my friends will present to you about our biodiesel plant costing. For introduction, estimation of capital and operating costs can be made by knowing the sizing information. Many engineering design projects are developed to achieve this. Chemical plants were made to gain profit, and estimation of the investment needed and the cost of production is required to calculate the profitability of a project. The cost of main equipment, raw material, and manpower has contributed greatly in the estimation process. The calculation of capital and operating costs is made in this section to analyze the economic feasibility of the biodiesel plant. Estimating the plant is important because it enables the company to decide about the manufacturing and selling policy. It is obvious that too high of estimate will not get any jobs for the firm quoting higher rates. Underestimating will put the engineering firm owner with a loss and may lead the engineering firm failure. Therefore, estimation must be carried out accurately.
Hi, my name is Mohammad Nazrin and I will continue on capital cost for land cost. Based on our plan layout here, the calculation of the land cost is according to the area of the land where 1337.84 meters times with 740 meters. The height of the soil that wanted to be accumulated is estimated for 0.5 meter. The area of the land is about 9.2 hectare and the cost of the land is estimated to be 50 million. To calculate land cost, first we must time volume of the industry site with cost of the soil. This means the 1337.84 meter time with 740 meter time with 0.5 meter and time with 13.2. We will get the total land cost around 6.5 million ringgit Malaysia. The price of the accumulated soil is obtained from the Jadwal Kadar Harga here from JKR. Next, I will pass it to Anissa.
Assalamualaikum, I am Anissa. Now I will continue with the capital cost for major equipment. So, the main equipment that we use are continuous stirred-tank reactor, cyclone, distillation column and heat exchanger. Below are the SAPC for year 2017 and year 2020. SAPC stands for Chemical Engineering Plant Cost Index that used to adjust process plant construction costs from one year to another year. The SAPC for 2017 is 572.9. SAPC for 2020 is 595.6. For the April 2020 is 2% lower than 2019. The currency is $1 equivalent to 4.04 ringgit Malaysia as January 2021. The first equation is used to calculate the purchase cost of the equipment at base condition. The second equation is used to calculate the pressure factor for process vessel. Next equation is used to determine bare module cost of the equipment. And this equation is used to calculate the total bare module cost in year 2020. And then this equation is used to convert the bare module cost in 2020 into ringgit Malaysia. Next, this table shows the equipment cost data to be used with the equations mentioned earlier. So we got description, K value and the capacity from the book called as Analysis, Synthesis and Design of Chemical Process. So I will show you this book. Okay, from this book, we got that from the Appendix A, and then go to page 988, and then it shows here. Next, for the pressure rating for heat exchanger unit, we got the description, C value and pressure range from this book also, at page 1006. From this we can get the pressure rating for heat exchanger. Next is the material factor for the identification number of material factor of the equipment. So we got the identification number, description and material of construction from the books also. This book, page 1008. Material factor, we got it from this book also, from this book at page 1009 from this graph. So when we got the identification number, so we can get the material factor. Next is the constant for bare module factor. So we got the description and the B value from the book also at appendix A at the same page from previous 1009 here. And then next we have to know the material factor based on identification number for trace also. So we got the identification number, description, material of construction and material factor from the same page as the major equipment, page 4012 for trace. So next, after we calculate using the equation that I've mentioned earlier, so we got the total bare module equipment cost for the main equipment. That's all from me. Nazrin will continue with the grassroots.
Thank you, Anissa, for the good presentation. Next, I will continue on with grassroots and total module cost. The total module cost is estimated based on the purchasing cost of the equipment for the plant process with 80% addition on the cost to consider for future expansion or alteration on the existing plant. To determine the grassroots cost, the auxiliary facility cost need to be evaluated altogether with the total bare module equipment cost. Here the formula for the grassroots cost, and here is the formula for the total module cost. For contingency and contractor fee, the contingency and fee costs are estimated to be 80% from the total bare module equipment cost. The contingency cost is estimated to cover the unexpected circumstance associated with the plan. The cost is estimated as follows. The contingency cost is 50% of the total bare module cost, around 1.6 million ringgit Malaysia, and the contractor fee is 3% of the total bare module cost, around 300,000 ringgit Malaysia. In total module cost, the total module cost is the total of the module equipment cost, contingency and contractor fee, where the total module cost is 12 million ringgit Malaysia. In total bare module equipment cost at base condition, the total base module cost at base condition is the cost of the equipment at ambient pressure with carbon steel as the material of construction. Therefore, the material factors of the reactors and heat exchanger is to be corrected to be carbon steel factor of material. Table below show the module equipment cost at base condition. We can see here the table here that total bare module equipment cost is around 1.9 million ringgit Malaysia. For auxiliary facility cost, the auxiliary facility cost include the site development cost, the auxiliary building cost, and the offsite utility cost. This cost is estimated at 50% of the bare module cost for the base condition. The auxiliary facility cost is 900,000 ringgit Malaysia. Next, grassroots cost. The grassroots cost is the sum of the total module cost and the cost of auxiliary facility. The total grassroots cost is around 13 million ringgit Malaysia. Next, I will pass it to Sabrina, and thank you.
Hi and Assalamualaikum, my name is Sabrina. Now I'm going to explain about the operation or manufacturing cost in our biodiesel plantation. The cost of the manufacture of a chemical must be measured as to identify the primary components of the cost of production. There are several factors that involving the cost of biodiesel manufacturing, which are direct manufacturing costs, fixed manufacturing costs, and general expenses. To obtain the cost of manufacture, we need to plus the direct manufacturing cost with the fixed manufacturing cost and also the general expenses. The following costs below must be known as to determine the COM, which are: the first point is fixed capital cost, second, cost of operating, third, cost of utilities, fourth, cost of waste treatment, and lastly, cost of raw material. Fixed capital investment, FCI. What is FCI? FCI is the expectation investment of stock of tangible, durable fixed assets held and all costs that associated with in building a plant for a year or more than 1 year. So the amount of FCI that we obtain is 13,604,035 ringgit 0.89 cents. So the total capital investment FCI is the totality of fixed capital investment FCI and the working capital investment WCI. WCI are basically set at 15% of the fixed capital investment FCI. So we calculated the amount of FCI and multiply with 0.15 and we get 2,040,605 ringgit 0.38 cents. And therefore the total capital investment with the formula of FCI plus WCI, we obtain 15,644,641 ringgit 0.27 cents. For the cost of operating labor, COL, we need to use the equation NOL, which is represent the number of operators per shift, NP is represent the number of operating steps, and lastly is NNP, the number of non-particular processing steps. To obtain the value of NNP, we have to use this formula, which is NNP is equal to the total of equipment. So based on this table, we have achieved the value of NNP, which is the total number of equipment for the NNP is 14. So the previous value of NNP, we can substitute the value of NNP in this equation and we get the amount of NOL is 3.08. And then the amount of shift per year of the plant, we calculated, we obtain 1,029 shift per year. For the amount of shift for a single operator in a year, we calculated, we obtain the amount is 245 shift per operator per year. And the number of operators that we needed are, we obtain from the calculation here, which is we get the 4.2 operators. From the number of operators that we achieve, which is 4.2, we multiplied by the NOL, which is 3.08, and the answer we got is 12.936. And which is the operators we needed, the number of operators that we needed are 13 operators. And the table below shown that the annual salary cost, which is the total cost for annual salary in our biodiesel plantation is 1,728,082 ringgit. The utilities that we use in our biodiesel plantations are firstly is electricity and also the potable water. So the cost of utilities per year is 1,239,380 ringgit and 90 cents. Now for the cost of raw materials. We have raw materials such as methanol and waste cooking oil. So the cost per year for the raw material we obtain is 34,277,688 ringgit 53 cents. For the cost of catalyst, we have catalyst such as sulfuric acid, and the cost per year is 824,018 ringgit 49 cents. While for the cost of waste treatment, washer, we apply washer in our plant as to neutralize the component while at the same time allow to remove any toxicity of impurities that contains in the compounds and produce high quality of product. So therefore, for our biodiesel plantation, we do not need any treatment for waste water since we have installed a washer in our plant that will take over to remove the small quantity of impurities. And lastly, the total manufacturing cost. As I have mentioned before, to obtain the cost of manufacture, the direct manufacturing cost is plus with the fixed manufacturing cost plus and with the general expenses. So to apply this equation, we have calculated the COM, the cost of manufacture, based on the figure here, which is the total for the COM we obtained is 52,200,489 ringgit and 31 cents. For the manufacturing cost without depreciation, which is COMD, is calculated by using the following equation as below. Okay, and we obtain COMD, and which we get 50,840,085 ringgit 0.72 cent. Okay, that's all from me. Thank you.
Hello, I'm Aina, and I'm going to continue explaining the last part of in this task, which is the fund economic feasibility. Okay, so for the first one is the initial cost or the net initial outflow. In order to find the net initial outflow, we need to calculate the cost of equipment, which is cost of equipment is the overall cost for equipment that are using in our plant, such like mixer, extrusion column, and washer, and so on. And then the next one is the subsidy or the external income. And then the working capital, raw materials such like methanol, and the catalyst that we are used. Okay, so the overall net initial outflow in our plant is the 45,777,598.39 cents. Okay, the table below shows the depreciation calculation in our plant. For the depreciation, we need to calculate based on the formula asset cost minus the salvage value and divided with the useful life of asset. Okay, what it means? Okay, based on the first table, which is the particular table and the amount. So this, the cost of equipment is our asset cost. We'll minus with the salvage value. So this is the salvage value. And with the useful life of asset, which is this is the value for the useful life of asset. So this is the formula. The value will enter to the formula, and the value for the depreciation is 2,813,058 ringgit 0.94 cent. Okay, so now is the statement profit before tax or PBT. So this is an example table for the PBT. In order to determine the PBT, we need to know the sales volume per unit, which is unit per year, the volume for the products over year. So this is the for the first year, and then this is for the second year, and this is for the third year. Okay, and then this is the sales price, which is the price for products per metric stone. And then we need to know the net sales, which is net sales is the sales volume times with the sales price, and then we got this one. Meanwhile, for the variable cost, at 60% of net sales is 60 over 100 times with the net sales, and then we got this one. And then for the fixed cost is the value from the grassroots or the fixed capital investment. Okay, and then this is the depreciation value, which is from the previous table. And then for the PBT, we need to minus the net sales minus with this one and this one and this one, and then we will get the value for PBT. Other than that is the statement net cash inflow. So to calculate the net cash inflow, we need to know the PBT first. So as I already mentioned, the PBT values that we got from the PBT table will be used for the net cash inflow. And then the tax 30% of PBT is the amount of 30 over 100 times with the PBT value. And then for the profit after tax is the PBT minus with the tax 30% of PBT. Depreciation same as I mentioned before. And then for the net cash inflow is the profit after tax plus with the depreciation. Okay, and then moving to the next slide is the discounted cash flow or DCF. To determine the discounted cash flow, we need to know the cash inflows values first, which is from the previous table. And then we need to know the PV factor for 12%. So in order to know the value for PV factor, this formula has to determine the values. The FV is the future value, which is the cash inflows value. And then R for the 12%, which is 0.12. And then N is the number of period, which is on for the first year, then we use first. If it in second year, and then we replace it with 2, and followed by in year 3. Then for the last one is the DCF value. So to determine the DCF value is the cash inflows times with the PV factor. Okay, so for the last one is the net present value or NPV. So the formula for NPV is the 3 discount cash inflows minus with the initial cash outflows. So this is the values, and the NPV value 773.95, 793.30 cents. As we discovered and studied, we conclude that the NPV value is positive and high. So the company should accept this project on the basis of economic feasibility analysis. Therefore, we can produce the best high quality of biodiesel product in the future development. So that's all from us. Thank you.